Hello and welcome to another episode of Invalid Entry. My name is James Terr and here we are doing the advent of code. We're doing some security related things. One of the things that I absolutely hate in computing is XML. XML is a curse upon us all, to be quite honest with you. The world would be a better place if we didn't have XML, is my opinion, and I will die on that hill. Yeah, that's happening. I'm going to demonstrate one of many issues with XML, and in the process I'm going to do it in Python, but this is true of all other languages because it's a problem with XML itself, the very way the XML is defined. And I'm going to show entity expansion today. Entity expansion is a bandwidth multiplication type attack. It's a way of an attacker who has less resources than the target being able to multiply that to cause a bigger impact. So if you imagine I might be an attacker, I might have a bunch of home computers affected by a virus or something, and I can use those to all send XML documents at a target server. That target server will open these documents and consume all its memory, and I'll demonstrate why. So first of all, I'm just going to import a couple of functions here. The first one is I'm going to have a thing here which I'm actually going to use parse string, which is from the XML DOM mini DOM. I could use Beautiful Soup, I could use some other libraries. The other libraries actually do quite a good job of avoiding these kinds of attacks, and actually even this library does quite a good job of avoiding it, which is the basic built-in XML parser for Python. But it still does suffer from it to a degree. I'm also just going to drop in here another function which is just going to do some pretty printing, so don't worry about that. The main one here is I'm going to do a trace malloc to actually work out how much memory I'm using and compare both the amount of memory I'm using at the end of this document load and the total amount of memory, the peak memory usage that was used during the parsing. The first thing we're going to do is we're just going to get a simple XML document. So here we go, simple XML document. Nothing to worry about here. It's got an XML, it's got a doc type root, it's got a test in it, okay? And we're just going to parse that document straight off. So to parse that document, I'm actually going to call test XML. So test XML, and I get some numbers back. And this used up a fair amount of memory actually for the size of the document. And that's just because opening a library, calling a function for the first time uses memory. What I'm going to do is I'm actually going to make a thing called run test. So I'm just going to show you this very quickly. What run test is, I prepared this. All we're going to do is we're going to take in a bunch of tests, which is going to be a dictionary, the name of the test, and the XML involved in it. We're going to run it 10 times. So we're going to do 10 repetitions. We're going to do 10 times, print off a load as we go, and return the output there. So that in. So now what we can do is go tests is an empty dictionary. Crack on with this where it's full power, so try to keep up. XML's here. So test simple XML equals that XML there. Nothing scary yet. If I actually spell my variables right, it all works fine. And now I can just redo run tests, that, and that produced an output. You shouldn't print in your functions. This is a bit of academic stuff. If I was better at this, print tabulate, one of my favourite things in all time. You can see that it's actually producing not a massive amount of memory. I'm passing 76 bytes in. It's using 36 kilobytes at peak. In fact, I'm just going to do a copy in a bit nicer headers here. Headers equals that. There you go. So you can see that its peak memory is 36 kilobytes, and the multiplier, what I'm interested in is how much of a percentage increase is it from my input to my total memory used. The problem with the very small bits of XML is that the library loading takes up quite a fair amount of memory. 36 kilobytes of memory isn't a lot for an XML library. So what we're going to do is we're just going to make more complicated XML to sort of show how much XML parsing can do. So the first thing I'm going to do is I'm going to generate some bigger XML. So I've got a function here. What we're going to do is we're going to generate a document which looks a bit like a library. So what we're going to do is we're going to bookshelf, we're going to books in it. We're going to have a random number of chapters and paragraphs. We're going to lorem ipsum generator to actually generate some paragraphs in there. And then we're going to dump the value into the XML. So with a D on the front for def, copy paste error. What we should be able to do now is go, actually, I want there to be a bigger block of XML here. I'm just going back to my run test, run all the tests again. And you can see there that I've now got a 94 kilobyte XML document. That's loading up 500 kilobytes of memory. So I'm getting about a 5 times multiplier. The multiplier drops because the overhead of loading the library isn't as big an impact. So now if we make that a bit bigger again, and then we replace that with a 2 more, so even bigger, and then even bigger 2, because I'm actually going to generate these two the same. I'm going to make that 100 and that 100. That'll take a few seconds to run because we're going to generate about 80 megabytes worth of data there. And this is going to be different files because of the randomness will be around the same size, but they'll be different. When I run these now, you'll notice actually that doing the even bigger one actually takes an interesting amount of time to process the XML. Even if it's an 80 megabyte document, a JSON file of 80 megabytes processes a lot faster than this does an XML file. XML files are slow, and I haven't even started using the funky bits of XML yet. So that was the even bigger, and now we process even bigger too. I've got, for those of you who are really interested, I've got a herbal tea inside of a Tim Hortons mug, which I think must be some kind of crime in Canada. And there we process those now. So if I look at the data now, nearly 80 meg the two files. The expansion ratio there is only double. So the amount of memory I'm using there is 170 meg at peak, and the output is about 167. That's all just when you've opened the XML up. That's all the metadata about each node, because you're actually going to create an object for every single node, and then have relationships between each other and pointers, all the rest of it. So yeah, it's not really expansion. You're not really creating a lot of memory here. This is where XML entities come in. This isn't true in JSON. You can't do this kind of attack in JSON, but you can in some YAML implementations. YAML allows you to put things like exclamation mark include statements into your YAML, so you can basically define that you can load, or you can have a function that gets called as you process the YAML. And if someone has a YAML which allows you to include, then you can use entities or something like that. You can do it. So very quickly, without even looking at this, I'm going to create a bad test. So a bad test is going to be another dictionary, and here my XML, it's going to be pretty much the same in that I'm going to have an entity, but then I'm going to define an entity here, and an entity can then be used. So I'm going to have my root. I can now do ampersand. Just make sure I haven't got off the bottom of the screen. I haven't got off the bottom of the screen here, which is good. Oh, I've lost my ampersand. There we go. Test. Okay, so this is this entity here. Okay, so when we do that, what we should now have is a nice XML document. Trouble like that. Bad tests start equals XML. And now what we're going to do is we're going to run this run tests, but we're going to pass bad tests in. And you see it runs out really fast, and then we're going to grab the output printer as well, because why not? Okay, so as you see now, I'm passing in 113 bytes using a 41 kilobytes of memory. Very, very similar to the first one. I haven't really done anything, because all I've done, if I actually now pretty print that, and pretty printing is this is bad XML. Ooh, nope, it's just XML. It shows that what it's actually done is it's taken this value here and put it in here. Okay, so the first thing we can do now is you can see this actually has expanded. So it says expanded, it's got a little bit bigger. It's gone from this big to being, this was the word test, so it's added in this many characters into memory. So the first thing you can do, actually, if you really want to optimize this out, is we can start making this a single letter thing like A, and then we can make this a bit longer. Okay, so I can make that, however big, a megabyte big or so on. And so I've got 143 bytes, and it's slowly making bigger memory. And to double it, I can now go and ampersand A. it's not really going up in memory because the overhead of using the library is too high. But we can make worse things than that. What we can start doing is we can start using this entity somewhere. So what I'm going to do now is I'm just going to copy this test here. I'm going to make a new cell, drop it in there, and this one's going to be bad test worse. And what I'm going to do here is I'm going to change this to being B, 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 two B's to start off with. And I'm going to make another entity, which is going to be entity B. And in B, I'm actually going to do two A's, like that. Okay? So when we run that now, with the worst test, you can see it's a few more bytes of memory, but I'm beginning to use up more memory, especially the end memory is beginning to creep up. Okay? And I can now double that. I can go a whole bunch of A's, like that. You see my end memory now is now sneaking up to 3 kilobytes. Okay? This is beginning to show that expansion. Then my expansion here is about 200 times multiplier. Again, it's nothing's going to crash in memory at this point. You can begin to get a bit daft. Okay? You can begin to start doing things like this, where I've now got 4 layers. So I'm going to call this Z layer A, B, C, D, and put the word hello there over and over again. So at this point, you've got a 300 byte, and it's beginning to use 76 kilobytes of memory. And that peak memory, which actually is what's slightly more interesting because that's where you're going to consume the most memory, and therefore it's now at 700 kilobytes. We can even go even worse than that. So let's just pump this. And I haven't changed the parser. I haven't put anything in the parser at this point to do anything worse than this. Even worse too. This is basically just longer. I've just expanded the number of elements on each side at this point. And run that now. Even worse too. Is now 300. It's now using 2.3 megabytes of memory, which for start means we're actually expanding by 6,000 times. Not 6,000%. It's 64,000. 641,000%. I'm expanding by 4 orders of magnitude. The input data isn't very long at all, so anything which has like an upload limit of like a megabyte, I'm well within that. So if I can post an XML file and you XML parse it, this will just blow this up. And we can go worse than that, of course we can. Now there is actually at this point a very good reason why I haven't gone bigger than this. You might go, oh, why don't you just go bigger? Why don't you go for the go mad, put like another 15 records in here. This is number 4. Run that again. So even worse, 3. Notice it's now taking an amount of time to actually process this request. We do this now. You have got a 400 byte input. It's producing a 14 megabyte memory. So again, if I've got a botnet, I can now start throwing, if I throw 100 of these requests at it, I then expand the memory by 33,000%. What's interesting here is if I expand this one just even a little bit more, so I'm just going to put that one up to another A in there, and actually run the thing here, it crashes. It just quits. The XML parser just quits, and it quits because the limit on the application factor, which is a part of the library I'm using. So what you've got to watch out for here is finding out actually what the limits of your entity expansion actually are on your library. You will be surprised at how many libraries let you go much larger. I think this quits at about 20 megabytes, or 20 megabytes more than the original file size I think it quits at. Because you can generate, obviously it loads up 80, 90 megabyte files. So you've got to be very careful, but I've seen libraries in some languages which will let you use up a gigabyte of memory with the default parsing settings. So usually settings you can pass into the parser to say, hey, limit the expansion, or don't allow expansion, don't allow entities. A lot of times I've used XML in my professional career, there have been no entities involved. So if you can turn off entities, and if you're using something like Beautiful Soup in Python, for example, you can turn off entities. That's the way to go. So if you know that the XML documents are well defined and they're actually just used as a data structure, like you would use JSON or YAML or any other data language, you could turn off entities. You have to be a bit careful and not turn off C data because you do have to escape certain values. But yeah, I would recommend that. The other option is stay away from XML. If you are a system engineer just saying I'm going to pass information to systems and you have the choice, I would suggest not using XML. I would use for data, raw data, I'd use JSON. For config files or human readable data, YAML. And the other reason for that is you'll find the peak memory and the time taken to process both JSON and YAML is significantly less for the same amount of information included. Now, there are reasons why XML is amazing. There's reasons around XLTs, transforms, where you can transform XMLs and things like that. However, I think there's new, more modern techniques of doing that. So I'm not convinced that you still need to do those things. And that's it. I just want to demonstrate how easy it is, how you can go from a very small amount of data into a very large amount. Bandwidth multiplications aren't limited to XML. There are other locations you can do bandwidth multiplications. One of the ones that springs to mind is DNS. There became quite a famous but a notorious attack that happened probably about 15 years ago now, where they used a threat group used DNS multiplication by sending. They had a very small number of computers. They sent DNS requests to a whole bunch of DNS proxies, open DNS proxies. And those DNS proxies then sent requests back onto the individual targets. So they were requesting a particular DNS, but they specifically sent their queries off to proxies who then sent it back to the target. That in itself is not really multiplication, because every request that went out then just got filtered in. It was more of a way of not knowing what your original set of IPs to block are. The multiplication came by they actually were able to send a small request to the proxies, and the proxies then expanded those requests into larger requests. So they reckon every byte that this attacker sent to the proxies then sent on about 4 or 5 kilobytes onto the main target. So that expansion factor then meant even with a small number of maliciously owned computers, you could then expand that to take down a server. That's all I've got time for today. So hopefully you're enjoying this, and hopefully you'll come back tomorrow for more security advent related things. Thank you very much. If you enjoyed these, please hit like, please subscribe, and I'll see you tomorrow.